Okay, so first task is read this first paragraph and see how it connects with this linear equation. Okay, and this line represents how much he'll be saving week by week. So this is the balance and the y-axis, basically the money in his account, and it's growing. And this is measuring every week. Okay. So the first thing we want to do is find the slope. So you can pick any 2 points. So I could say this is $5 in 2 weeks. Sorry, it's $10. That's $10 in 2 weeks. So the rise is 10, the run is 2. That's basically $5 per week. So where do we see the slope in the equation? So let's look at the equation. Where do we see that? This $5 per week. Let's see. I see it right there. How would we describe that location? What do we call? Do you remember what we call a number that multiplies next to a variable? Starts with a C. It's the coefficient. It's the coefficient. I know we're kind of all brain dead, including myself, because of a long test we took. So I'll give you a slide on that. It's a coefficient. But seriously, I'm thinking of making a vocabulary test at some point. Part B, where does the graph intersect the y-axis? So where's it crossing the y-axis? At what number? Here's a line. It crosses at 10. $10 to be exact. Okay, where do we see that value in the equation? You see it in the equation up here? It's right there. Okay, let's link this all back to the original problem. Where did we see $5? Where did we see $5 in the original question? You see it here? But notice it says each week. It's a rate. Okay, so it's basically our rate. How about the $10? Where do we see that in our original equation? Yeah, that's what he started with. His savings account started with $10. and then it grows by $5 each week. So that was enough information to write the equation, and it's also going to be enough information to graph. Okay, so let's go ahead and go to slope-intercept form. Slope-intercept form, or y equals mx plus b. Does that sound familiar from last year? Mx plus b, y equals mx plus b. Is one way to write an equation of a basically linear relationship. It's the most common way. So if we have an equation that graphs a line, basically a linear function, then hopefully we can write it this way because it's the most useful way to do that. Okay, so let's find out the various parts. The m value, this coefficient for x, is going to be the slope. And does anyone remember what we called the b value? Y-intercept, yeah. Y-intercept. So y equals mx plus b. If you have an equation written in this format, slope-intercept form, you already know the slope of the line, how steep it's going to be, and you know where it's going to start on the y-axis. Okay, so we're going to use that definition to answer questions 1 through 4. So for questions 1 through 4, I want you to look at the equation, identify what the slope number is and what the y-intercept number is. Okay, so I'll give you about a minute to do that. Go ahead and go through it and write down what the slope value is, what the y-intercept value is. You can work with your partners. Carlos, why don't you work with Gabriel? Okay. And maybe Jose, you can work with well, let's just do that. Yeah, let's do Jose, work with Dayanara. Okay, so compare what you got to what I have. Okay, so for number 1, as long as you find the coefficient and the constant, you have the slope and the y-intercept in that order. So this is the slope and the y-intercept. So here it's negative 1/7, and since we don't have a constant, it's 0. Here it's negative 1 for the slope. Our coefficient for x is negative 1, and negative 8 for the y-intercept. And finally, they could be in reverse order, but the coefficient for x is 3/2, so that's the slope, and the constant is positive 15, so there you go. Okay? So let's move on. So in these questions, we're going to write the equation in slope-intercept form, but first we have to identify what the slope and the y-intercept is. So they gave us a graph, and the first thing I always look for is the y-intercept, because that's a quick number to find. Would you agree that it looks like it's crossing at 18? So 18 is my y-intercept. Let's find the slope now. So I'm going to pick a couple of integral points, maybe here and here. And let's see, I'm going to start at this point further to the left. I'm going to go down. How much am I moving down? Negative 4, right? 2 spots, but each spot is 2. So it's negative 4. Thank you. That is negative 4. And then we're going to move, we're counting on the x-axis, we're counting by 1. So this is just positive 1. So the slope is negative 4 over 1 or just negative 4. So the slope is negative 4 and the y-intercept is 18. What would the equation be? Y equals, we want to write it in this format, like this. So it would be y equals, uh-huh, 18. Y equals negative 4x plus 18. So go ahead, work with your partner on 6 and 7. Okay, try 6 and 7. And make sure you agree. So number 6, I found the y-intercept is 3, then a slope of 3 over 2. So what should the equation be? Y equals 3 over 2x. Well, where's it? Remember, for the plus or minus, it's whatever. Gabriel, no. Okay, where's it crossing? Crossing the y-axis at 3, so plus 3. Okay. Number 7, it's crossing at negative 2, and the slope is negative 1 over 3. So hopefully this is what you got. Y equals negative 1/3 x minus 2. Okay. So the last thing we're going to cover is how to use this to graph. So we've gone over how to identify the slope and the y-intercept in an equation, how to take the graph of a line and write the equation in slope-intercept form. Now let's actually graph. Okay. So Gabriel, do me a favor. Read this top part here.
All right. 8 up through 10. Plot the y-intercept, then use the slope of rise over run to plot a second point of the graph. Draw a line connecting the points to create a graph of linear relationship.
Okay. So what we're going to do is you're going to identify, look at the equation, identify the y-intercept, then plot the y-intercept. Then you're going to use rise over run for slope to plot a second point on the graph and draw a line. So this is where our rulers come into play. Okay, so what I'm going to do first is I'm going to write M and B. And the first number I always identify is the slope, 2 over 3. The second number, the y-intercept, negative 4. Okay, so the directions say plot the y-intercept. So where am I plotting negative 4? Where am I finding negative 4? On the x-axis or the y-axis? Where should I? The y-axis. It's always on the y-axis. So here's negative 4 on the y-axis. The line crosses there. Now we're going to use rise over run. So from this point, I'm going to rise 2 and run across to the right 3. 1, 2, 3. Right there. So my first point will be right there. Up 2 spots, across to the right 3. Okay. And ideally you want a third point, but sometimes you can't find one. So I think that's the case here. So my line will go like this. Okay. Up 2 across 3 from the y-intercept point. And there's our line. Okay. So let's find the y-intercept, the slope and the y-intercept for the rest of these, and then you can graph them. Let's take a look at number 9. What's my slope number? What's the number for the slope? Negative 5. I want to write this one though, since it's ideally for For graphing, you want it as a fraction, a rise and a run. -5/1. So if you get an integer, give it a denominator of 1. Where's it crossing the y-axis? 20. Yeah, 45. Okay, so let's find that. 45 is here, so that's my starting point. Then I want to go down 5/1. Down 5/1. Down 5/1. I could find a few points if I want. I went down 5 across 1. So this is the graph for this. Okay, so I'd like you to try number 10 with your partner. Negative y equals -1/2 x. Remember, find the slope, and then identify also the y-intercept, the b value. Okay, so what's the slope value? -1/2. And how about the b value, the y-intercept? 0. So this one will go through the origin. Okay, so find your y-intercept value at 0. And this is telling me down 1/2. Okay, down 1/2. So going down 1 is going to be a little tough, right? What are we counting by on the y-axis? 2's. So I have to go down a half step because that's 1. And then over a whole step because that's 2. So it's going to be, yeah. So if you went down across 2, remember, we're counting by 2's here on our scale. So if you need to go down 1, you go half a step. And then if you need to go to the right 2, you're going to go across a whole step. So it's going to be like so. When you're graphing these, always be aware of your scale. Okay. All right. So let's try number 11, then you'll try 12. Let's see here. I'm going to highlight this particular point here. Why am I interested at x equals 0? Because it's what? Not only the smallest, it is the smallest, I'll give you that, although we might argue -2 is smaller than 0, but it is 0. So when x is 0, yeah, if x is 0, you find your point. That's where the y-intercept is. So this is the y-intercept value. So we have to identify the y-intercept number. It's the y value when x is 0. Pay attention, please. So when x is 0, what's y?
-3.
That's your y-intercept. Always look for x being 0, and that's where your next value is going to be. Okay, so let's find the slope. Let's find the rate of change. We went up by 2 here, right? Plus 2. And here we also increased. So if I'm going from negative 1.4 to 0.2, what's the difference? How much am I going up by? 1.6. So now let's find the difference in y over the difference in x. It's 1.6 over 2. Right? The increase was 1.6 rather, and here it was 2. So the difference in y over the difference in x is 1.6 over 2, which is 0.8. 1.6 divided by 2 is 0.8. So the slope is 0.8. So now let's write the equation. Y equals mx plus b is y equals, what am I multiplying x with? 0.8. Y equals 0.8x minus 3. So you got to find the y-intercept. If they give it to you as 0, you've already found it. And then the rate of change. So try that on number 12. Try that on number 12. And finding the y-intercept's easy. So check in with your partner, see if you agree. We'll start with the easy one. What's the y-intercept number? 35. Right there. Okay. And then if I'm going from 200 to 356, 365 rather, that would be what? 165. So our change in y was 165. Our change in x was 3. So what's that going to be? 165 divided by 3. Okay, so y equals 55 times x plus 35. So looks like whoever hired this plumber had to pay $35 just for him to visit. Then he charges $55 an hour. So just to show up, it'll be $35 and $55 for every hour. Okay, last one, you're going to work with your partner here. So this graph shows the linear relationship between the number of minutes Ingrid has traveled and the number of miles she is from her work. So you're going to write an equation. We're going to determine what is the rate of change and what does it represent, and what's the y-intercept and what does it represent, and when y is 0, what is the value of x when y is 0. So be careful on that one. This time on the last question D, we're interested what happens when y is 0. And what does it this point represent? Okay. I want you to think it through. Put your brains together and work on that. Y equals 0. When y equals 0, what's x? So when y equals 0 is here, right? Here's 0. Where are we on the x-axis when that happens? 18. And what are we measuring on the x-axis? Yeah, the minutes, and that's minutes to get to work. So, or back. So we could say it takes Ingrid 18 minutes in this case to get home. Because the graph is going downwards. Okay. All right, so the assignment is on delta. Oh, 4 miles per 3 minutes. Yes, you're right. It should be 4 miles every 3 minutes. Hmm. Per 4 miles every 3 minutes. Thank you.